29 I heard. I done did heard 29. Okay. Yeah, so number 29 is that I'm guessing a word?
Yes.
Can you do me a favor and get it open? Read it for me?
You have a piece of wood that is 72 inches long. You cut the wood into 3 pieces. The second piece is 6 inches longer than the first. The third is 6 inches longer than the second. Draw a diagram and then write and solve an equation to find the lengths of the 3 pieces.
Okay. All right. So you've got a 72-inch piece of wood. That you're going to cut up into 3 pieces. Okay. So the first piece is going to be that long, and then the second piece is going to be 6 inches longer than that, and then the next piece is going to be 6 inches longer than that, which is really 12 inches longer than the first one, right? Okay. So let's call this one X. So X is going to be the first piece. Then the next piece would be X plus 6. And then the next piece would be X plus 6, which is X plus 12. Okay? So X plus 6 plus X plus 12 has to be 72. And they're all in inches in this case, so I don't have to worry about switching back and forth between feet and inches and 0.5s and 1s and that kind of a thing. Okay? So that gives me 3x plus 18 equals 72. Subtracting 18 from both sides, that gives me 3x equals 54, which gives me x equals 18. But the question was asking what is the dimensions or what is the length of each piece, correct? Find the lengths of all 3 pieces. So the first piece is going to be 18 inches. The second piece is going to be 24 inches. And the third piece is going to be 30 inches. So there's really 3 answers to that particular problem. And then just a quick check. 30 plus 24 is 54, plus 10 is 64, plus 8 is 72, so it works out to be 72 inches. Other questions? Yes, Sam? Number 30. You got it out? Yeah. Okay, read it for me, my man.
You want to take 5 posters on a wall so that the spaces between posters are the same. You also want the spaces at the left and right of the group of posters to be 3 times the space between any adjacent posters. The wall is 50 feet wide and the posters are 1.5 feet wide.
So the posters are 1.5 feet, and the wall is how long? How big? 15. And there's 5 posters. Okay. So then this is 1.5. This is 1.5, 1.5, 1.5, and 1.5, right? And then in between, we'll call that X, because we don't know. Right? And then on the outside, you said something about 3 times the width in between? Yeah? So then that would be 3x out here and 3x out there. Okay? So there's 5 times 1.5 plus 3x plus 1, 2, 3, 4x is in the middle, plus then another 3x is going to be 15. $7.5 here. 10x equals 15. So 10x is 7.5. So x is going to be 0.75 feet. Okay. Or, so 0.7, I would accept their 0.75 feet between each poster. Or if you wanted to switch that into inches, make that 9 inches in between each poster. And then, I'm guessing it also asked for the outside dimensions too? Like find the positioning, probably is what it said. Out of position. So we had 9 inches in between, and then 27 inches on the left and right sides. Or, what would that be? 2.25 feet. Either way, both are the exact same. And one's just in feet, the other one's just in inches. Good? Because you kind of have, no? Okay. Yes, ma'am. 31? So boxes, right? Okay. So in terms of that one, each box, there's 20 total boxes, right? Okay. So if I have 2 boxes of clothes, how many boxes of books would I have then? How many boxes of books would I have? If there's 20 total boxes, and I have 2 boxes of clothes, you'd have 18, right? Okay. If I have 5 boxes of clothes, how many book boxes do I have? 15. If I have X boxes of clothes, how many boxes of books do I have? 20 minus X. Yep. Okay. That was the trick on that one. Okay. Good. We'll put it over here today. When you're ready, it doesn't have to be right now. If you want to fix someone, at some point in time before you leave, make sure you get that turned in. Okay? So, today we are going to solve or deal with linear inequalities. Okay? So, before we get into the linear inequalities, let's talk a little bit about what inequalities we're talking about. Okay? So, less than is that symbol. Okay. Greater than is that symbol. Less than or equal to. Greater than or equal to. And then the other one that we have is not equal, which is an equal sign with a slash. I don't really care which direction your slash is going, but it just has a slash. You've seen those all before. Probably don't need to write those down, but if you want to write them down, that's fine. Okay? Now, the kicker with the inequalities is that I could write this down. X is less than 4. Right? But that could also be four is greater than X. Red and blue there are saying the exact same thing. Okay? They're saying the exact same thing. Okay? It all just depends on what side you put the numbers and what side you put the variables on. Okay? So just know that you may have one answer. You may be writing it in the blue form. Okay? But somebody that your neighbor, your shoulder partner, if you will, might be writing it in the red form. Okay? You're talking the exact same language. Okay? You're just not writing it the exact same way, but you're both right. Okay? Just saying. Okay? When we graph inequalities, okay, in this I don't want to say basic case, but we'll get up to, in the next couple of weeks, we'll jump up to where we graph linear inequalities, and then there'll be two-dimensional. Okay? But right now we're dealing with just a single variable inequality, so it's the basic one. Okay? And those are graphed on a number line. Okay? The number line has two parts to it. Okay? So the first part is the dot. So it is either on or above the number on the number line. Okay? And it is either open or it's closed, depending upon which inequality you're dealing with. If you're dealing with the equals cases, so less than or equal to, greater than or equal to, you fill in that circle, that dot. Right? If you're dealing with just less than or greater than, you leave that dot unfilled. You just draw a circle. Okay? Then you have the arrow part. And I'll show you how or why I mean that the arrow goes above the number line here in a minute. Okay? So let's deal with that whole x is less than 4 problem that we just did. Okay? So there are two ways that you could do this. Okay? My first way is, actually here, let me do this, and let me do that, and let me do this, and that, and this, and that, and this, and that. Okay? Now, there's a lot of thises and that's. Okay? Alright? So my first way that I'm going to show you is I'm going to show you where the only number that I'm concerned about here is 4. So that's the only number that I have to put on my number line. If you want to put more numbers on there, that's your own choice. You don't need to. 4 is the only number that absolutely positively has to be on it. Okay? What kind of a dot am I using? Open or closed? Open. Okay? So this first one is going to be the more common one. And so what's going to happen here is you're going to put an open, here let me go in this color so it sticks out a little bit. You're going to put an open circle around that number. Okay? And then we want an arrow above the line, and we want the arrow to show numbers that are all less than 4. Well, which way is less than? Where on a number line, where are the smaller numbers? To the left, right? Okay. So I'm going to go up and left from there. Okay. Another way, an alternative way to do that exact same problem, again, you're only dealing with the number 4, and then this time, excuse me, we'll do just the open above the 4, and then go left with that. Okay. What I don't want to see is this. Okay? And here's why. I'll show you. Do you see it? Because I don't. I don't. You got to make it so that it's known. Okay? Now, if you wanted to, you could do a third way. I'll do it all in one color. Okay? I see that. Okay? But here on this not way, I don't see that. Okay? And I did them all in one color because more than likely you're probably going to do your homework all in one color or a test all in one color. Now, if you want to break out the highlighters or the colored pencils and stuff like that, hey, I'm all about color. Make it look pretty. Okay? But you don't have to. Okay? Or if you want to break out pens and stuff like that, whatevs. Okay? Your call. Just got to be clearly seen by somebody else other than you. Okay? When we are solving inequalities, we solve inequalities the exact same way as we solve equalities. So remember that, whatever we do to one side, we do to the other. To move stuff, we do the opposite. We try and get the variables on one side and the numbers on the other side, and we check our answers. Okay? We still do all of that. Okay, but one super huge extra rule here, and hashtag, we'll even go hashtag on this one. Hashtag, write this down. WTD, that's what we hashtag WTD. Okay, write this down. If you multiply or divide by a negative number, okay, only a negative number. It's not if you multiply, it's not if you divide. It's only if you multiply or divide by a negative number that inequality needs to flip around. Okay? So if it was less than, it becomes greater than. If it was greater than or equal to, it becomes less than or equal to. Okay? Totes important. Okay? Totally important. Okay? Know that. Well, last year's it was hashtag know this. I see that now. This year it's hashtag write this down. Okay? Alright? We ready? Let's try some. Okay? So, your homework this evening is going to have a lot of solves and graphs. And so you're going to go through and you're going to solve the problem. And then that's going to be half of your answer is the inequality solved. The other half of your answer is going to be the graph of that solved inequality. Okay? So, on this first one, the very first thing that I would do is I would divide both sides by 4. Now, you may ask yourself, I'm dividing. I need to flip that sign. But do we have to do that? We're dividing by a positive number. So I don't have to flip that sign. Okay? So this then becomes x is greater than or equal to 6. So let's make that into a number line. Only number I'm concerned about is 6. Open or closed dot? Closed dot. And am I going to the left or to the right? I want numbers bigger than 6, which happen there. Okay. Quick, easy check. 0 is your favorite number. Okay? 4 times 0 is 0. Is 0 bigger than or equal to 24? It's not. It's not. And so, sweet. Okay? And 0 is over here in the area that is not got an arrow going to it. So we should get a false answer. So it checks out. Okay? What I'd like you to do now is I would like you to do these next 2. So first I would subtract 20. So that gives me 3x is less than negative 12. Then I'm going to divide by 3. Do I need to flip my sign? No, because I'm dividing by a positive number. Yes, the number that I'm dividing into is negative, but I'm dividing by a positive number. So that sign does not have to flip. So that still is x is less than negative 4. Negative 4 is the number that I'm looking at. Open or closed, it is open. And I want numbers smaller than negative 4. So I am going to the left. Concur? Concur. In this one, I'm going to subtract 8 off the start. That gives me negative x is greater than positive 9. Then I'm going to divide by negative 1. So ding, 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 what's got to happen? I got to flip my inequality because I am dividing by a negative number. And that gives me that. Only number I care about is negative 9. I want open circle, and I want to go to the left. On this particular page, skip D. Just do E and F. I just worked out D just because, I'm OCD like that, but so that one works out. But in E, okay, I subtracted 2 from both sides. Got 10 is less than or equal to negative 4x. Divided both sides by negative 4, which flipped my sign. Okay, so my sign became greater than. And then 10 divided by negative 4, I'm leaving that as negative 5/2. Okay? Which is fine with me because it's the only number that's going to go on my number line. So whatever the fraction is, if you had it in decimal form, whichever form you put it in, okay, it can go on your number line. And we're going to the left. Okay. So that is that one. on this particular one, first off, what I would do is I would distribute this 5. So then that gives me 5x minus 6 is less than or equal to 5x plus 5. Subtracting 5x from both sides. And then adding or subtracting, we'll add 6 to both sides. Or if you want to subtract 5 from both sides, that gives me 0 here is less than or equal to 11. Ruh-roh, what's wrong? The what? There's no variable, okay? So you have to ask yourself, is that a true statement or is that a false statement? That one is a true statement, right? So in that case, then, our answer is going to be all real numbers. How we graph all real numbers on a number line is the arrow goes all the way through. Or the line, I should say. You draw a second line above everything. Okay? Now, if this were a false statement, okay? So if that were a false statement, your answer would be no solution. And your number line would have nothing on it. Okay? Because there is no solution for it. Okay? With me on that? Compound inequalities now. There are two different kinds. This first kind is an AND type, which means that both parts must be true. So both parts there have to be true. And the cool thing is, it's going to end up looking like the handle on a suitcase. Okay? So it's going to look like that. So in this particular case, it would look like I would have -4 and +8, and then I would have in it, so this one would be a filled in dot, this one would be an open dot, and I'd have a handle that looked like that. The other one is an OR type, and an OR case only one part has to be true. And the cool thing about it being an or case is, for those of you that have ever rowed a boat before, okay, this one is going to look like since the Gophers hired PJ Fleck and his saying is row the boat, and I'm a Gopher, we're going to row the boat. Okay? Alright? So this one is going to look like a rowboat. What was that? Row the boat. So in this particular example, we would have 3 and 7, and then we would be open here and going that way, and we would be open here, bad one, and going that way. Now, when you actually do these type problems, and there's things to actually be done in them, the hint on this kind is do those two together. By meaning of that is, I want to get x by itself, so I'm going to subtract 5, which means I'm going to subtract 5 there, and I'm going to subtract 5 there. I've got to do it all at one time. I got to subtract 5 in all of my parts. Okay? So then that becomes negative 15 is less than 3x is less than 3. Then I'm going to divide everywhere by 3. Again, if I divided by a negative, both of those inequalities would change. And so that then gives me negative 5 is less than x is less than 1. On a number line, now I've got two numbers that I need to be concerned about, negative 5 and positive 1. In both cases, I'm going to have open dots and a handle going in between. I know I dropped one. In the OR case, the hint is you're going to work those out individually. Okay? So I'm going to add 1 here. That's going to be 2x is less than or equal to negative 6. Divide by 2. X is less than or equal to negative 3. Subtract 3. 4x is greater than or equal to 4. Divide 4. X is greater than or equal to positive 1. So my answer then would be x is less than or equal to negative 3, or x is greater than or equal to 1. On a number line, negative 3, positive 1, filled in dot at negative 3, going to the left, filled in dot at positive 1, going to the right. questions on those? Tonight's homework, 1.6, 7 through 29 odds, 40 through 46 evens, 49, 50, and 53. Now it seems like a lot, but really, those first, the 7 through 26 odds are like, add 3 to both sides and you got it solved. Or divide, add 2 and divide by 3. So it's like 2 steppers to get them solved. So there's not a lot of meat